Our next type of object comparison is using a comparator. Now, in a comparator, the structure looks very similar, but we can create unlimited number of comparators because we're kind of actually interfacing with the class, which is different than having this introspective. So we're just saying, hey, this is going to work with our employee class. This is going to work with our student class, but it's not physically embedded in here. Matter of fact, I'll show you here. Well, I better show you now because I just talked about it. But in our comparator setup, you'll notice I'm not implementing anything, and I really don't have the compare to. Even if I had the compare to method, what I'm going to do is actually circumvent it using the comparator code. So let me get back up there real quick though. Is that it's basically the same idea as a compare to. We're going to be interfacing it from another class or object here. It's usually very simple to create. Matter of fact, to be honest with you, I usually copy and paste the ones I've already established, change them slightly for my next one, and then we go from there. It's used to compare both homogeneous and heterogeneous objects. So the only comparator that we were allowed, or comparable allowed, didn't cover. So you can create different combinations of the comparator once I get to it. But here's the class setup. But this is what the overall comparator looks like. So I'm showing you two different versions of a comparator here. First for a string, and then another one for a value or an integer or some type of numeric value here. When we're doing a comparator for a string, let's first look at the overall general setup. Number one, we have class full name. So notice it has a completely different object. I put it in capital letters, really honestly. For me, you don't have to do that, but you'll see where I kind of use that a little bit later on. Implements a comparator, and this is how we tie it to an employee, saying, hey, when I use the employee, this is what we're going to be using in order to compare. Notice it doesn't say compare to. It says compare employee A and employee B. Now, the interesting part about this is you know how to do a comparison when it comes to strings. We have to use Java's base string compare function called compare to. Okay? That's the base compare to just for strings. But notice this compare function actually returns an integer. The reason is, and it's very similar in many other languages, is that we can have certain numbers that let us know, okay, does one go before the other? If we happen to return a 0 from this compare function, it means they're exactly the same. We had two objects of employees that were exactly the same, and that sounds weird, but hey, it could happen, okay? A -1 means that this one needs to go before, A needs to go before B, and then a 1 says, hey, you know what, these are in the wrong order, let's swap A and B in the order that they were given. Now remember, the game plan is that we are looking at our first name and last name, so that's how this is being ordered. So your game plan or your design on exactly how you wanted to sort is here. And that's why I give you another one down below, because this one, it still works with employee. It's called a different, and frankly, makes sense what it's doing here. I'm doing an age, and it is just comparing the ages. But notice again, there's my if, else to return my -1, 1, and 0. Now, why don't I need the -1, 1s, and 0s here? Because the compare to functions for strings already do that. That's the only reason why I had to really spell it out for numeric values. And again, it's the same idea on making sure what order that we have things in. So just a heads up on the difference between the two. But again, public int compared to employee A, employee B. Here we're just checking the ages. So in reality, notice they're so similar between the two of them. That's a beautiful part because frankly, I can do some copy and paste. Hey, we're all lazy. But that's how the comparator is going to work for a string and for an integer or a numeric data type. Here comes the code and the power of a comparator. Setting up an array list, added about 3 employees, really displaying it. And that's what it is. So we have Lupoli, McLaughlin, and Joyce. And again, that's really from this order that we have here. I'm going through there. I'm just displaying that order to make sure it's right. And then after that, I am doing a comparison. Now, in that comparison, I'm really actually doing a collections.sort. But notice it's not just the array list that I'm passing in. I'm also telling it how I want it to be done. And that's by full name. So now you know why the comparator was an object. That object had specific instructions on how I wanted to compare employees. So I'm physically passing that object in full name here into my collection sort, and then it'll do that Joyce, Lupoli, and McLaughlin. Now, afterwards, we would do, it's another example, but I could do the exact same thing for age. And honestly, I don't think I put age in there. Oh, I did. So at the end of that, when everything's said and done, it'd be me, then it looks like Peter Joyce, and then McLaughlin would be displayed after I did it. But notice, I'm using the same array list. I didn't have to change anything about it. The sort did the work for me, and really, the comparator did all the work for me too.